So dear student, now let's move on. Let's calculate the second illustration of the chapter. Actually, this second illustration is very much important because whatever the answer we get in this example, that answer itself is an equation for the other MCQs and other sums. So please be carefully, please seriously observe this illustration. It's most important for the 12th standard also. Now question is, find the magnitude and direction of resultant of two vectors A and B. So here suppose we can think two vectors A and B, and we would like to find their resultant vector. After getting the resultant vector, we would like to find the magnitude of resultant vector as well as direction of resultant vector in terms of the magnitude and angle theta between them. You will understand the question once I will draw the diagram. So please observe this diagram. For example, let's consider this is x-axis and let's consider this is y-axis. Okay, so this is xy plane. Now let's assume two vectors A and B. For example, suppose this is vector A. Let's call it this is vector A. As we understand in the previous topic that this vector is exactly parallel to x-axis. It has only one component. So we can write the equation of vector A. Vector A has only one component, that is the x component. So vector A equals to ax I caret. Now let's assume another vector B. Suppose this is vector B, and suppose vector A and vector B, angle between them is suppose theta. Theta is the angle between given two vector. Now if we think for vector B, so vector B has two component, x component, y component. So equation of vector B we can write in this way, bx I caret plus by j caret, because it has two component, vector B has two component. Now according to parallelogram method, this is vector A and vector B. Both the vectors are already connected with a tail and tail combination. So first of all, complete the parallelogram. After completing the parallelogram, draw the diagonal. Diagonal gives you a resultant vector. So this is our resultant vector R. Let's call it R is the resultant vector. And remember, R is the resultant of A and B, vector A plus vector B. So R is the resultant vector. Now again, if you look at the question, find the magnitude and direction of resultant of two vectors A and B. This is vector A and this is vector B. This is the resultant of A and B. We would like to find the magnitude of this resultant vector as well as direction of the resultant vector. Okay, so let's first of all find the resultant vector, equation of resultant vector. So now resultant vector, we know that R is the resultant vector and is the resultant of vector A and vector B. So we can write in this way, vector A means ax I caret and vector B means bx I caret plus by j caret. This is vector B and this is vector A. So R is the resultant vector. We can write in this way also, vector R is equals to, from these two term we can take I caret common. So ax plus bx I caret plus last term is by j caret. So dear student, this is the equation of resultant vector. In this diagram we have total three vectors A. This is the equation of vector A. This is vector B. This is the equation of vector B. And red one is the resultant vector and this is the equation of resultant vector. Let's call it equation number 1. But we would like to find magnitude of resultant vector. Now dear student, try to remember the previous topic, how to get the magnitude. To get the magnitude, we know the rule, square root of the square of the sum of the component gives the magnitude of resultant vector. So now let's find the magnitude of resultant vector. This is our resultant vector, and now magnitude of resultant vector. Magnitude means you can write only R without an arrow, or you can write in a mode also. So this is the magnitude. Now look at the here, along with I caret, this is the X component and this is the Y component along with J caret. So first of all, I'll write the component. X component is AX plus BX is the X component of resultant vector, and BY is the Y component of resultant vector. Now according to rule, square root of the square of the sum of the components gives the magnitude of any vector. So let's simplify. Square root of A plus B all square, according to that concept, AX plus BX all square means AX square plus 2AX BX plus BX square plus last term is BY square. Now dear student, if you observe this equation, so for example, suppose vector A is equals to 4I caret, so we can immediately give the answer if anyone asks us that what is the magnitude of vector A. So 4 is the magnitude of vector A. So in the same way, here look at this equation. What is the magnitude of vector A? So AX is the magnitude of vector A. And here, what is the magnitude of vector B? So BA has two components. Magnitude of vector B means under root of BX square plus BY square. These are the components. Square root of the sum of the components gives the magnitude of vector B. And since vector A has only one component, so that is the magnitude of vector A. So here instead of AX, we can write only A also. Without an arrow, it's a magnitude. So instead of AX square, we can write A square plus 2. AX means A, BX as it is, plus look at this last two term, BX square plus BY square. BX square plus BY square. If you remove this square root, so we can write B square also. This is B square. Finally, we can write in this way, under root of A square plus B square plus 2A. BX, actually BX is what? We understand in the previous topic, okay, if any vector is like that, has two components. This is the X component, this is the Y component. Suppose this is vector B, so its X component is B cos theta and its Y component is B sin theta. In the previous topic, we derived the equation of component. B cos theta and B sin theta are the components. So this Bx is the X component. Instead of that, we can write B cos theta. This is the equation of magnitude of vector B. It's most important equation. Let's call it equation number 2. So one answer is obtained. They ask us to find the magnitude. Magnitude of resultant vector is obtained. A square plus B square plus 2AB cos theta raised to 1/2. We can also write in this way. Magnitude of vector R means A square plus B square plus 2AB cos theta. Instead of square root, you can write raised to 1/2 also. So this is the first answer. This is the magnitude of the resultant vector. Now we would like to find the direction also. Direction means, let's assume, suppose this resultant vector makes an angle alpha with the x-axis. So let's find the angle alpha. That resultant vector makes how much angle with x-axis? It represents the direction of the resultant vector. Now according to this geometry, let's draw, this is the head of the resultant vector. From the head, let's draw one perpendicular line. Now this is vector B. Please look at here. This is vector B. So we can also think this is also vector B. Just only difference is that here vector A and vector B is connected with tail and tail combination. You can think that vector B imagine to be here. Vector B imagine to be here. So this is also vector B. Now let's give the name of triangle OPQ triangle. OPQ triangle. Remember this is x-axis. So in this right angle triangle OPQ, okay, in this triangle OPQ, triangle OPQ. Look at this triangle OPQ. This angle is alpha, tan alpha. We know that tan means opposite side upon adjacent side. So this angle, its opposite side is PQ and adjacent side is OQ, O to Q. Okay, further simplify, PQ upon OQ. Now dear student, look at here, O to Q. Let's divide into two parts, ON plus NQ, ON plus NQ. So tan alpha is equals to, now look at here, P to Q. Now look at here, this is vector B. As we know that it has two components, this is the X component and this one is the Y component. So this is the Y component of vector B and that is equals to B sin theta. So here PQ is equivalent to B sin theta. PQ is equivalent to B sin theta. So here instead of PQ we can write B sin theta. Now ON, look at the ON. ON itself is our vector A, but we write only A. It's in a magnitude plus NQ. Now dear student, look at this NQ. This is vector B and look at here, this is vector B. As we know that if vector B is like that, so if you draw the perpendicular line, so this is the X component, BX. So in the same way, this is vector B. So this is the X component of vector B, BX. And here instead of NQ we can write BX also. So tan alpha is equals to B sin theta upon A plus BX. X component of vector B is B cos theta. So this is the equation. Through that we can get the angle alpha also. This equation also can be written in this way. Alpha is equals to tan inverse B sin theta upon A plus B cos theta. So this is the angle alpha made by the resultant vector with the x-axis. And look at the answer. This direction, angle alpha, is in terms of magnitude of A and B, and in terms of theta, angle between this given two vector. So my advice is that please remember this equation for the next few MCQs which are not given in our textbook, but we definitely will calculate few MCQ which based on this equation is the most powerful, most important equation of this entire illustration. Remember, if you have two vectors A and B, so magnitude of their resultant is A square plus B square plus 2AB cos theta raised to 1/2, where this theta is the angle between vector A and vector B. Whatever the two vectors over here, theta is the angle between these two vectors. So A square plus B square plus 2AB cos theta raised to 1/2. This equation is most important one, and this equation actually tells us, gives us the magnitude of resultant vector, and the last one gives us the direction of resultant vector. So this is your illustration number 2, example number 2 of the textbook. So now dear student, let's calculate one MCQ which gives us the understanding of that previous example. This MCQ is the MCQ out of textbook, but through that MCQ we can understand the importance of the previous equation that we derived as an answer in the previous example. So now question is mode of A plus B. Mode means magnitude, magnitude of A plus B. A plus B means we have two vectors A and B. Plus means resultant of vector A and vector B. So magnitude of the resultant of A and B should be equal to magnitude of the subtraction of A and B. It means that magnitude of addition of A and B and magnitude of subtraction of this two vector A and B should be equal. Then what is the angle between two vectors? We can calculate this MCQ through the calculation as well as through the logical also. We done it in a both way. For example, first of all, our requirement is mode of A plus B. We want equals to mode of A minus B. Just before some time in the previous example, we already derived the magnitude of resultant vector. This is the magnitude of resultant of A and B. this is the magnitude of resultant of A and B. We can write in this way, A square plus B square plus 2AB cos theta raised to 1 half. This is the magnitude of resultant of A and B. Should be equals to, now on the right hand side there is a subtraction of A and B. So this equation in case of subtraction can be written in this way, A square plus B square minus 2AB cos theta raised to 1 half. Agar there is a plus sign, it's a resultant of A and B, and minus sign subtraction of A and B. This equation we derived in the previous example, but in the same way, agar if there is a magnitude of subtraction of two vector, so answer will be A square plus B square minus 2AB cos theta. Now in this equation, theta is the angle between A and B, theta is the angle between A and B, and we would like to find that theta angle. Okay, now on both sides there is a square root which is removed. So here A square plus B square plus 2AB cos theta should be equals to A square plus B square minus 2AB cos theta. Raised to 1 half is removed from both the side. Now here A square plus B square and A square plus B square is also cancelled from the both the side. 2AB cos theta and minus 2AB cos theta, take it on the left hand side, so it will become plus 2AB cos theta. 2AB cos theta plus 2AB cos theta means 4AB cos theta is equals to 0. It means that cos theta is equals to 0, 0. This 4AB, if you take it in the denominator, 0 upon 4AB 0. So cos theta is 0, dear student, theta is equals to 90, because you should know that cos 90, its value is 0. Cos 90 is 0. Agar cos theta is 0, so theta equals to 90. Means that these two vectors A and B should be perpendicular to each other. Now let's check this answer is correct or not. Cross check. Look at here. Suppose this is vector A. From the head, try to recall the triangle method for the vector addition. From the head, now I'll draw vector B. Look at here. Here A and B vectors are perpendicular to each other. Vector A and vector B are perpendicular to each other. Okay, so according to the triangle method, this is vector A. From the head, this is B. Tail of the first to head of the last, this is A plus B. This is A plus B. Now let's do the subtraction. This is vector A. Agar this is vector B, so this is vector minus B, opposite in direction. Again, according to triangle method, tail of the first to head of the last is known as A minus B. Now in this diagram, it is very clear from this diagram that length of A plus B, magnitude of A plus B and magnitude of A minus B are equal. It is equal only if angle between these two vectors is 90 degree, otherwise not. For example, I'll draw the wrong diagram. For example, suppose this is vector A and this is vector B. So this is the resultant of A and B, this is A plus B. Now this is vector A. From the head this is B, so this is minus B. Opposite to B is minus B. So this is A minus B. Now look at this diagram, you will easily understand. Look at the length of addition. The magnitude of A plus B and magnitude of A minus B are not same. Is same only if two vectors are perpendicular to each other, otherwise not. So answer of this MCQ is 90 degree. Option B is the correct answer. कि अगर magnitude of addition of two vectors and magnitude of subtraction of two vectors are same, is only same agar angle between this given two vector is 90 degree. Again, dear student, related to the same concept, this is the example number 3 from the textbook. It's an illustration number 3. Now question is, a motor boat is racing towards north and the speed of the motorboat is 25 km per hour. Okay, look at the diagram. Consider first of all east, south, west and north. So this is east, west, north and south. Now again read the question. Motorboat is racing towards north. Motorboat is going towards north with the speed 25 km per hour. Okay, so I'll draw one vector which represents the velocity of boat VB, that is 25 kilometer per hour. That motorboat is going towards north direction and with this speed 25 kilometer per hour. Now there is a water current, the flow of river. Water current in that region is 10 kilometer per hour. It means that the water of the river is flowing with this speed 10 kilometer per hour. In which direction? So in the direction of 60 degree east of south. Okay, this is east and this is south. East of south means from the south towards east at an angle 60 degree. This vector represents the velocity of current, of the water current, and this angle is 60 degree. From the south at an angle 60 degree towards east, this is the direction of water current and that is 10 kilometer per hour. So we have two values. One is velocity of the boat, and in that region the river, water of the river is flowing with the speed 10 kilometer per hour, making an angle 60 degree from south towards east. So question is, find the resultant velocity of boat. So we have two vectors. One vector represents the velocity of boat, one vector represents the velocity of water current. Now according to parallelogram method, dear student, according to parallelogram method, first of all complete the parallelogram and now draw the diagonal. Diagonal is your resultant vector. This is the resultant vector R, which represents the resultant velocity of motor boat. This is the resultant velocity of boat that we would like to obtain. Now is very clear कि भाई this total angle is 180 degree. 180 degree. Out of 180 degree subtract the 60 degree. It means के this angle is 180 minus 60 means 120 degree. That is the angle between VC and VB, these two vector. Now let's use the previous concept. Magnitude of the resultant vector, which is a resultant velocity of the motorboat. Magnitude of the resultant vector mod R is equals to a square plus b square plus 2ab cos theta raised to 1 half. As per this concept, we have two vectors VB and VC. So VB square plus VC square plus 2VB VC cos theta raised to 1 half gives the magnitude of this resultant vector. Where remember theta is the angle between VB and VC, and this is VB, velocity of boat, velocity of water current, angle between them is 120 degree. Now let's put the value. VB square, VB is 25, it's in a 25 square plus VC is 10 kilometer per hour, 10 square plus 2, VB is again 25, VC 10 cos, angle between these two vectors is 120 degree raised to 1 half. Now 25 square, square of 25 is 625 plus 10 square means 100 plus 10 25 is 250, 252 is 500. Now cos 120, dear student, value of cos 120 is minus 1 half raised to 1 half. Remember, cos 120 is equals to minus 1 half, cos 60 is 1 half, cos 120 degrees this in the second quadrant. So that in the second quadrant cos function is negative. Value of cos 120 degree, remember, minus 1 half. Okay, so this is 625 plus 100. This negative sign will come here, minus 500 by 2 is 250 raised to 1 half. This is 725 minus 250 all raised to 1 half. Final answer will be approximately 22 kilometer per hour. You can check yourself. This is the resultant velocity of the boat in the presence of flow of river, in the presence of water current. Actually boat is moving with the speed 25 kilometer per hour, but remember, this is the speed of the boat if there is no water current. But due to the presence of water current, now your boat will exactly not go towards north, it goes somewhere in this direction and with the velocity 22 km per hour. So this is the answer. They ask us to find the resultant velocity of the boat. So resultant velocity of the boat is 22 km per hour. Now further, you can find the direction also. Okay, by this resultant velocity of the boat, make suppose angle 5 with the velocity of boat. So you can, according to the trigonometric concept, you can find this angle also. But now check this angle is how much? Yourself. Okay. So now dear students, let's understand one MCQ again from out of the textbook, but very easy, and also the application of that equation which we derived in the illustration number 2nd. Before calculate this MCQ, before solve this question, again I just want to recall you, okay, agar we have two vectors A and vector B, then magnitude of the resultant vector is a square plus b square plus 2ab cos theta raised to 1/2 gives the magnitude of resultant vector. On the base of this, let's calculate, let's solve this question. Two forces, one is 5 Newton, another one is 10 Newton, act on an object. So there is a one object, two forces are acting on an object, one is 5 Newton, one is 10 Newton. Angle between these two forces is 60 degree. Okay, for example, suppose this is an object lying on the table, two forces are acting, suppose one is 5 Newton, another one is 10 Newton, and angle between these two forces is 60 degree. They ask us to find the magnitude of resultant vector. So we have two vectors, one is vector of force of 5 Newton, another one is vector of force of 10 Newton, and we also have the angle between these two vectors 60 degree, and we would like to find the magnitude of resultant force. So look at the solution. Magnitude of resultant force, magnitude of the resultant force is 5 square as per equation a square plus b square plus 2ab cos theta. So first force 5 Newton, 5 square plus second force 10 Newton, 10 square plus 2 ab cos theta means 5 10 cos theta raised to 1/2 gives the magnitude of the resultant force. And here theta is actually the angle between these two forces, and which is given to us 5 Newton and 10 Newton. These two forces, angle between them is 60 degree. So we will put 60 degree over here, is equals to 5 square 25, 10 square 100 plus 10 5s are 50, 52s are 100, and cos 60, value of cos 60 1/2 raised to 1/2. Okay, so 100 plus 25 125 plus 100 by 2 is 50 raised to 1/2. So here 125 plus 50 175 raised to 1/2. Now you should know that 13 square is 169. So that should be quite more than 169. So and 14 square is 196. So that is less than 196. So answer will be somewhere between 13 and 14. Square root of 125 is 13.22 Newton. So this is the answer. The magnitude of the resultant force. Agar two forces are acting on an object, 5 Newton and 10 Newton, according to parallelogram method, this is the resultant force, and resultant force is of magnitude 13.22 Newton is the magnitude of resultant force. Now I hope you understand the application of this equation. Always remember, okay, if we have two vectors, vector A and vector B, so magnitude of the resultant vector is, equation is a square plus b square plus 2ab cos theta raised to 1/2. And also remember one more point, if we have two vectors A and B, magnitude of the subtraction of these two vectors is a square plus b square minus 2ab cos theta raised to 1/2 gives the magnitude of the subtraction of two vectors. This gives the magnitude of addition of two vectors. So these two equations are very much helpful in solving few concepts in a shortcut way.